For example 7, I'm going to be graphing another piecewise function like we did in example 6. And the first thing that I'm going to do is break up my graph paper. I have 3 different equations that need to be graphed in 3 different spots on my graph paper. So the first equation is y equal 4, and that function is going to get graphed to the left of -1, including the endpoint of -1. The less than or equal to symbol is telling me that it includes that endpoint because a little extra equals there. And so I'm going to break up my graph right there at -1. And as I said, y equal 4 is going to be graphed over there. Then the second function that we have is y equal 4 minus x squared. And that is going to be graphed between -1 and 2, including the endpoint of 2. So that's going to be a closed circle, but not including the endpoint of -1 because it doesn't have the equal sign underneath the symbol. And so I'm going to break up my graph because my interval goes from -1 to 2. I'm going to break it up at 2. It's already broken up at -1. I'm going to put that in there. And again, you can erase these lines later. And the equation in the middle part of my graph is going to be y equals 4 minus x squared. And then finally, the last part of my graph, for any x value that's greater than 2, I'm going to have the equation y equal 2x minus 6. And that is going to be an open circle and not include that point. Now, y equal 4 is the equation of a horizontal line. And y equal 4 minus x squared is a parabola opening downward. I know an x squared is a quadratic, which is a parabola, and the negative sign means it opens down, so that's going to be the shape of the middle one. And then the last graph is the equation of a line. It's a linear equation with a slope of up 2 over 1, so he's going to be pretty steep, probably steeper than that. All right, I'm going to use an XY table to graph these just because it is going to be quick for the example. I was going to do the graphing calculator, but it's just going to take a long time, and I'll probably put that at a later date. Okay, so y equal 4, you don't actually need an XY table for that, but I'm going to put one in anyway. And if I were to make an XY table, I'd have to use values that are to the left or equal to -1. So maybe I would pick -4, -3, -2, -1. You can put in however many you like. You really only need probably like 2 points to graph it, but if you wanted to use a table, but just put in 3. So when x is 3, then y is still 4 because there's nowhere to put in that x. When x is 2, y is still 4 because there's nowhere to put in that x. And I have nowhere to plug in my -1 to calculate some kind of new value, so still y is 4. And then you can see that makes a horizontal line. And you're back 3 up, 1, 2, 3, 4. Back 2 up 4, back 1 up 4, and I am including the -1 in my interval, so it's going to be a closed circle. It says for x values less than or equal to -1, so I get to use that point. Now the second function or equation in my piecewise function is a little more difficult because it is a quadratic, and you need more than just 2 points to graph a quadratic. You're going to need a few ordered pairs in there to make that nice smooth U shape. When you graph a line, you really only need 2 points, and when you graph a horizontal line, technically you only need 1 point. but for the parabola, you are going to need a bunch of points. So I'm going to make my XY table. And then we're going to go ahead and pick some ordered pairs. Now, technically, I am not allowed to use the -1. It's not included in the domain. But I'm still going to put that in my table to see where that location is. And then instead of filling it in, I'm going to actually put an open circle. So I'm kind of cheating and using a point that I'm really not supposed to be using. So from -1 up to 2, so let's go ahead and use every whole number x value, -1, 0, 1, and 2. I'm going to put that in my equation and calculate a y value and graph those points. So then I have 4 minus -1 squared, and that ends up being 4 minus 1, which is 3. And then I have 4 minus 0 squared, and 4 minus 0 is 4. And then we have 4 minus +1 squared, that's 4 minus 1, which is back to 3. And then finally 4 minus 2 squared, and 4 minus 2 squared is 4 minus 4, which is 0. Now I have an illegal point in there that I'm really not supposed to be using. I'm not supposed to be using an x value of -1 to plug into my xy table. So technically this guy doesn't even count. But I am going to use that -1, 3 just to find the location to put my open circle. So I can be like very, very close to that break, or the end of that interval. All right, so I'm going to graph. We're going to go -1 and up 1, 2, 3. Once again, not really allowed to use that point, so that's going to be an open circle. And then we have 0 up 4, and over 1 up 3, and then over 2 up 0. And I am going to fill that in because I'm allowed to use the 2 in that ordered pair. And then we're going to draw a nice smooth curve, and that one's done. Alrighty, last one is y equal 2x minus 6. That is a linear equation, straight line. I could graph that using slope-intercept, but I'm just going to make it easy and use an xy table for consistency with the other two graphs we made. And I am technically not allowed to use the x value of 2. It's supposed to be x values greater than 2, but I'm going to cheat and use that 2 anyway, just so I can find the location to actually put that open circle. And then I only need 2 points to graph a line, but I'll just do 3 anyway. So let's do 2, 3, and 4. Those are all numbers greater than 2. Well, not really, but 3 and 4 are numbers greater than 2. And 2 is actually our little illegal point we're going to do. And then I'm going to plug in 2 times 2 minus 6, which is -2. And 3 times 2 minus 6, that's 0. And 4 times 2 minus 6 is 2. And let's go ahead and graph that. We are over 2, down 2, open circle. That's my cheaty point that I'm really not supposed to be using. And then we are over 3, up 0, and then over 4, up 2. And I'm just going to connect and draw an arrow on the end of that. Okay, so that is my piecewise graph using an XY table. Once again, you kind of should have a feel for what you're graphing ahead of time based on what your equations in your piecewise look like. Each piece represent a different type of y equals equation. Like this is y equal 4, and this is y equal 4 minus x squared, and this is y equals 2x minus 6. And you should know that if you only have a constant, it is a horizontal line. If you have an x squared, you're going to have a parabola. If your parabola has a negative in front of it, it's upside down. It opens downward. If you have an equation in y equal mx plus b form, then it's the equation of a line, and it's just going to be a line with some kind of slope. And I will in the future show you how to use the graphing calculator to do the piecewise function.